Hi, today we're looking at writing a linear function or a linear inequality that models a relationship between two quantities. You are looking to write your equation or inequality in slope-intercept form. So you'll be writing in y equals mx plus b form if it's an equation. You know it's an equation if you have a line only. If it's an inequality, there will be shading. So look at example 1. That is a line only. So we know that this graph represents an equation. Start by finding the y-intercept. Where does it cross the y-axis? When x is 0, y is 1. So we know that the b in y equals mx plus b is 1. Then find the slope. Be sure you use the slope and make sure that the slope works as you move up and down the line. So it appears to be that the slope is down 3, right 2. But I'm going to test that by going down 3, right 2 and seeing if I still fall on the line. And I'm going to continue that in both directions to make sure that I didn't make a mistake in the slope. So negative 3 over 2 works. When I move along the line, I stay on the line using the rise of negative 3 and the run of positive 2. So that's the m in y equals mx plus b. Now you're ready to write your equation, which means it'll have an equals. So y equals negative 3 over 2x plus 1. Example 2. We look at that, we see shading, so we immediately know that this graph represents an inequality because there's shading. Again, we're going to write the inequality using the symbol less than, greater than, less than equal, or greater than equal. But we're going to keep it in y is one of these symbols and mx plus b. Looking at the line, it is dashed, so it has to be less than or greater than. Start with the y-intercept. The y-intercept is where it crosses the y-axis, 0, negative 4. So this will be b in y equals mx plus b. Find the slope. I am going from negative 4 up 1 over 4 maybe. How do I know for sure? I'm going to check it. Up 1 over 4 and I'm still on the line. I'm going to go the other way, down 1, left 4, still on the line, down 1, left 4, still on the line. I am rising from left to right, so the slope is positive 1/4. So we know that the equation is y is some relationship to positive 1/4 x minus 4. Just like when we decide which side of the line to shade, we're going to pick a point and test it to see what symbol we should use. I'm going to use 0, 0 because 0, 0 is a solution. So when I plug in 0 for y, 1/4 times 0 is 0. 0 minus 4 is negative 4. What relationship is 0 to negative 4? 0 is greater than negative 4. So the symbol is going to be a greater than. Without the equals, since we have a dashed line, we know it's just greater than. The points on the line are not solutions. Y is greater than 1/4 x minus 4. Moving on, we're writing the equation of a line, so equals, that has a slope of negative 3 over 2, so m, and a y-intercept of 11, so b. This seems pretty simple, and it is. I'm giving you everything you need. Y equals negative 3 over 2x plus 11. I gave you the slope, I gave you the y-intercept. But looking at example 4, I am not giving you the y-intercept. I am simply giving you a point on the line. I am giving you the slope. So 10, 8 represents a point on the line. To find b, we're going to substitute 10 for x, y for 8, and 1/5 for m in the equation y equals mx plus b. When we do that, the only thing that will be missing is the b. So now we have an equation with one unknown value. We can solve for b. So multiply 1/5 times 10, put my whole number over 1. 1 times 10 is 10. 5 times 1 is 5. 10 divided by 5 is 2. So now I have 8 equals 2 plus b. Solve for b by subtracting 2, since 2 is positive. 2 minus 2 is 0, leaving me with b equals 6. Go back to the directions. Determine the equation of this line. I have not written the equation yet, but I have everything I need to write the equation. Y equals 1/5 x plus 6 is the equation of the line. Example 4 is very similar. Example 5, except I only have 2 points on the line. So what 2 things do I need to write the equation of the line? I need the slope and I need the y-intercept. Given 2 points and neither point is the y-intercept, how do I know when I have the y-intercept? I have an x value of 0. Given 2 points, first find the slope. So the first thing I'm going to do is use the slope formula to find the slope. So y sub 2 is 1 minus negative 9 over 3 minus negative 3. So that turns into minus a negative, which is a plus, 10 over 6, which is 5 over 3. So I know that the slope is 5 over 3. Now that I know the slope, I can use the slope and either one of these points to find the y-intercept, doing the same step we did in the previous example. Substitute into y equals mx plus b and solve for b. So y is 1, m is 5 over 3, x is 3. I used this point. I have to use the x and y of one of the points. I picked this one simply because it was positive. You could have picked either point. It doesn't matter. Do the multiplication. 5/3 times 3. 3 over 1. 15 divided by 3 is 5. So I have 1 equals 5 plus b. Get b by itself by subtracting 5. 1 minus 5 is negative 4. So we know that the b value is negative 4. Go back and read the directions. The directions say create the equation. I have not written the equation yet, but I have everything I need to write the equation. So the equation is y equals 5/3 x minus 4. Example 6, write the equation of the graph below. It is an equation because it's a line only. This seems simple. It seems very similar to the first example. However, I cannot precisely tell what that y-intercept is. So, when I ask for the y-intercept for the equation, I do not know. And we want to be precise. So let's then see if we can use this graph to find the slope. So if I look for points on the line, this appears to be a point. This appears to be a point. That would be a slope of 1, 2, 3, 4, 5 over 3. Let me go the other direction and see if 5 over 3 gets me to another point. Oh, that looks like it's a point on the line. 1, 2, 3, 4, 5 over 3. So it looks like 5 over 3 is the slope that stays on this line. So the slope is 5 over 3. Now, what I've just bolded here in red are 4 whole number points that are on this graph. Let's pick any one of them and use it to find the precise value of the y-intercept. Since it's somewhere between 0 and -1, we can't quite tell. So let's use 4, 6. You could have used 1, 1. You could have used -2, -4. You could use any point on the line, but I'm just going to use 4, 6. So 4 is an x, 6 is a y, and the slope is an m. So plug that into y equals mx plus b, and you get 6 equals 5/3 times 4 plus b. Put my whole number over 1. 6 equals 20/3 plus b. 20 is not divisible by 3. Subtract 20/3 from both sides. To subtract a fraction, I need a common denominator. 6/1 is equal to how many over 3? 1 times 3. So 6 times 3 is 18. So I have 18/3, which is the same as 6, minus 20/3. 18/3 minus 20/3. 18 minus 20 is -2/3 equals b. So I found my y-intercept. Does it make sense? We said the y-intercept was somewhere between 0 and -1, and -2/3 makes perfect sense because that is somewhere between 0 and -1. So what is the equation of the line? Y equals 5/3 x minus 2/3. Common mistake is forgetting to put the x. Do not forget the x or the y if you are solving and you have a slope and a y-intercept. The only time x is missing is when your slope is 0. The only time y is missing is when your slope is undefined. So in summary, when you're asked to write the equation of a line and you're given a graph or you're giving points on the line, you should be thinking y equals mx plus b if it's an equation, and then obviously if it's an inequality, you would use one of your inequality symbols. Dashed line would be less than or greater than. Solid line would be less than, equal to, or greater than equal to. Now try the practice problems. Thank you.